Assalamualaikum. My name is Mohammad Nafiz Hussain. Welcome to my video class. Today we will solve a shear force diagram and bending moment diagram, a triangular section horizontal in a horizontal beam. There have one support and two support, and length was 6 meter. At the 6 kilonewton, the uniform load. So first we need to find reaction force of RA and RB. So we need the convert the uniform load, uniform triangular load to a point load. Half into base into height. Half into base is 3, height is 6. So here is 9 kilonewton. So, and distance was 12 by 3 and L by 3. 9 kilonewton. So we need moment equation to find RA, reaction. Summation of moment of A equal to 0. So moment 9 into L by 3. L by 3 or 3 by 3. L is 3. L equal to 3. Then clockwise is positive and anti-clockwise is negative. So the reaction of RB into 3 plus 3, 6. RB into 6 minus RB into 6. So we find RB here 1.5 kilonewton. Then equilibrium, the upper load and lower load. Equilibrium of upper load and lower load. So upper load is 9 kilonewton and lower load is RA into RA plus RB. So upper load equal to lower load. Upper load is 9 kilonewton equal to lower load RA plus RB. So RA equal to 9 kilonewton minus RB. 9 kilonewton minus 1.5 kilonewton, or is 7.5 kilonewton. So here is 7.5 kilonewton and the RB equal to 1.5 kilonewton. Then we need to draw SFD from the reaction of RA, RB and the uniform load. Here the SFD is 7.5. 7.5 is 7.5 kilonewton and the uniform load is 9. So 9 is load is down going. So uniform is load is negative. So 9.5 9 minus 7.5, so 1.5. So here is the triangular section. So the load SFD is curve. So here is 1.5 and there have no point load, so this is going then RB is 1.5 minus uploading load, so 0. Now we find BMD. So we need to know the section of X, and there are the total is 3 minus X. So there have some equation to find of X. That is the equation to find simply X. W X square divided by 2L equal to F. W equal to load acting on uniform load. X is the length of hair, and L is the total of the section is 3 meter, and F is the smaller load. Here smaller load is 1.5 kilonewton. We don't need 7.5. We need smaller load 1.5 kilonewton. So X equal to root over 2FL divided by W. So here 2 into F 1.5 into L 3 divided by W is 6. So here there is 1.22. X is 1.22. So the distance is X to 1.22. So here is 3 minus X. 3 minus 1.22. So there is 3 minus 1.22. 3 minus 1.22 is 1.78. So here the length 1.78 meter. Is meter also. So this is the point. We denote D. To find the D of uniform load. D here uniform load. So we find uniform load here. So there are some equation to find out uniform load. Wx by L. D point uniform load Wx by L. W is the load, total load 6 into X is 1.22, L is 3. So we find uniform load at D. 2.44 kilonewton per meter. So here is 2.44 kilonewton per meter. Now we find the moment at D. So we use right hand side beam to find out moment of D. So moment of D equal to, clockwise is positive, anti-clockwise is negative. So here is load point, that is the triangle. Therefore uniform load is 2.44. So here the point load half into base is 1.22 and height is 2.44. Then I find two into 2.44, 1.48, 1.484, 1.4884. Now this is acting on L by 3 and 2L by 3. So L by 3, 1.4884 into L by 3. L by 3 is, L is 1.22 here, and L by 3. L by 3 is clockwise, acting on clockwise, and then is anti-clockwise. 3 plus 1.22, 4.22. So 1.5 minus 1.5 into 4.22. So we find 1.44488 into 4 into 1.22 divided by 3 minus 1.5 into 4.22. So we find 5.7 minus 5.72, but there are a minus is neglected because this is positive and this is negative. So here we find 5.72. Here we find 5.72 moment, bending moment. It is curve this, and now we need to point C. We need to point C moment. So we need left hand side to find out moment of C. So
again.
So 7.2 is kilonewton per meter. Here is kilonewton per meter. Now we find the point C moment, bending moment. So we need left hand side to find out bending moment C. So summation of moment of C equal to 7.5 is clockwise is positive, anti-clockwise is negative. 7.5 into 3, anti-clockwise 9 into 2L by 3 minus 9 into 2 into L is 3 divided by 3. So we find 7.5 into 3 minus 9 into 2, 4.5. So here the moment is 4.5. Here is the moment is 4.5 kilonewton per meter. Now use this portion to find next moment, next bending moment. So here is negative. So 1.5 into 3, 1.5 into 3, 1.5 into 3, 4.5. So 4.5 minus 4.5 equal to 0. So here is 0. So here the bending moment BMD we find. So we use these equations to find many types of triangular section. Suppose this is the triangular section, or every triangular section we need this equation to simply find out the bending moment. Thank you.